Welcome everyone to the first online meeting of the NorCal chapter of Association of Energy Engineers. We are living in strange times right now with the pandemic going on and many of us in lockdown and some of us even losing loved ones. It's a difficult time. Everyone needs to adapt and that's what we are trying to do with this Zoom event. Today we have with us Steve Kelley, the Senior Vice President at Engie eMobility, and he's going to speak to us about energy storage and microgrid technology. Before we proceed, let me introduce you to our chapter president, Tim Clark. He's a certified energy manager and a certified M&V professional with Association of Energy Engineers. He has over 35 years of experience in the built energy efficiency industry, and he has a technical manager at Johnson Controls looking at all aspects of a sustainable built environment. With that, over to you, Tim.
Okay, good. Thank you, Nishant. Great to see everybody. I see many familiar names and faces on the Zoom meeting here. It's great that we could finally get together. Last time we were together in person was February 20th at our UC Davis Med Center tour. So little beknownst to any of us at the time, we were standing right at ground zero for all this pandemic in California. But it's good to see you all here, and looking forward to staying active in our industry locally here with some virtual chapter meetings and in-person meetings, hopefully before too long. So I just wanted to go over a few things that the chapter have been doing, and maybe a little discussion, maybe that you could maybe glean some knowledge of what the chapter does, our local activities may interest you that we've done in the past. So if you go to the next slide, please, Nishant. You'll see one of the annual programs that we put on is a scholarship for college students. This year we had several applicants, actually very good applicants. It was difficult to decide amongst the two. I think we got over almost a dozen applicants. We selected a junior at Cal State Chico, Lydia Altman, in mechanical engineering, and Kyle Donahue, a junior at Sac State in electrical engineering, and awarded them scholarship monies, and they were distributed. So hopefully those donations and the contributions you've made to the chapter in the past, you can see that it's going right back out to the students in the in form of scholarships locally to build the future of our industry here in Northern California. So that's one of the things that we do annually. Nishant this year headed that up, and so great job, Nishant, on that scholarship program that you administered. Okay, if you go to the next slide then, Nishant, I did want to make everybody aware that AEE National Organization has started a career hub on their website, and this is maybe a particular interest to somebody looking for work or employers looking for qualified applicants. It just serves as kind of an industry-centric job posting board. So you'll find it there at the aeecenter.org website under the resources page. So hopefully that's a benefit to you all if you take advantage of that. So next slide, please. This is kind of a little recap of the events that we've done in this 2019-20 year of ours. We start off every year in September. This year we had a presentation by Dan Mendonça. Dan, at the time, was the energy manager for Sacramento County. He had a great presentation on net zero and very engaging. And so we really all enjoyed that and learned a lot. In October, we had a social event that Brian Lina hosted, our annual Oktoberfest craft brewing that was a lot of fun, and got to know some new people and made friends there. In November, we had a meeting that we had a speaker from the Sacramento Valley Electric Vehicle Association, Mr. Guy Hall, gave us a very engaging and discussion-provoking conversation about electric vehicles. I think everybody learned a lot, and if nothing else, we probably came away from there with a new appreciation for the past, present, and future of electric vehicles. So that was a really good program. And thank you, Josh Sarpardar at ABM, for hosting that at his conference room there in Sacramento. Okay, in December, we got up to Chico State University and visited with the Alternative Energy Club that they have there. And they showed us some of their projects. We talked to them a little bit about careers in the energy industry. Very engaging group, and as a result, we've got some new members from the Chico University, and as well as one of our scholarship recipients came from Chico this year. Well, naturally, while we're in Chico, we had to combine that with a tour of the Sierra Nevada Brewing Company, which many of you may know has world-class sustainability efforts that go on there. And so we've gone there. I think this is the third tour we've done over the last 10 or so years. So it's always interesting to see what they've added, what new technologies they're deploying, and to kind of check up on them there to understand how industry is embracing sustainability and how they're employing the new technologies. So similarly, in January, we went to Vacaville to the Genentech facility there where they do biotechnical production of cancer treatment drugs. Our own member, Mitch Corso, gave us a facility tour there. Absolutely amazing that the things they do with they're the highest in technology, the state of the art in just about every system that's in the building. We're looking to stay in contact with Mitch and Genentech because they have a really, really ambitious sustainability program where their goal is, I believe, within 3 years to go to all natural organic refrigerants. And so we want to stay in touch and learn more about his progress with that effort. Okay, as I mentioned in February, we're at UC Davis Med Center for a tour of the central plant. Brian Linus set that up with our host, Bob Tomlinson. Absolutely amazing tour and awesome facility. And it was just a really, really educational visit to see the scale of what they're, the central plant there and how they maintain that huge, I think it's over a 3 million square foot campus there at UC Davis Med Center. Well, naturally, as you know, we were on hold due to the pandemic for March and April, and now we're back with our virtual presentation this afternoon by Steve Kelley for energy storage and microgrid technology. In June, we may have a program, probably a virtual program, and we're still putting that together to try to develop a program. Normally June is our awards meeting and social event. And then we take a summer break, July and August, and then we'll be back with more programs, hopefully again in person, or maybe a combination of in-person and virtual meetings in September. So that's just a little taste of what our chapter does, and I wanted to share that with you. Hopefully you decide to get involved and participate. Hopefully you're receiving the newsletter and can stay in contact with us by that. So again, thank you all for joining this afternoon. Look forward to a great presentation here. And then Nishant, if you go to the next slide for me, please. I did want to recognize the board of directors for the chapter that does all the work to put these events on and keep the chapter going. I couldn't do it by myself at all, but I've got a great team on the board. My vice president is Josh Sharpetar. Josh is on the line now. He just got off the airplane and jumped on this Zoom meeting. But Josh, and then together with Fred Twaits as our secretary, and Fred also puts on a killer trivia night. So hopefully sometime in the future we get an opportunity to have another trivia night. All the work that you guys do is just really appreciated. One of our founding members, Brian Lina, is our treasurer, puts in a ton of work on the chapter every year. And then member of the board and past president, Brian Tanahashi, is very active. And then naturally Nishant does several programs a year and conducts the scholarship program and in his capacity as member at large. So thank you all the board members of AEE NorCal chapter. Really appreciate all your efforts. Okay, well with that, Nishant, if you'll advance to the next slide. I will take this opportunity to introduce our speaker for this afternoon, Steve Kelley, Senior Vice President of Engie Mobility. And Steve's a graduate of UC Berkeley. Go Bears. He's spent over 25 years in the industry in high tech and the solar and renewables sector, and now finds himself associated with the transportation industry. So maybe we'll learn more about that in the presentation. But Steve, so glad to have you, and thank you for hosting this presentation. Look forward to learning a lot. So at this point, I will thank you again and just turn it over to you, Steve.
Tim, thank you so much. And that was a pretty impressive list of past speakers and presentations you have. So I got my work cut out for me. But I was happy to see you got up to Sierra Nevada Brewery. That is one of our clients. I was one of the founders of Engie Storage, which prior to being acquired by Engie was called Green Charge Networks. So I've spent now almost 8 years in the battery storage industry. And in March of this year, I convinced Engie to develop an eMobility team, which is really focused on electrification of fleets as well as hydrogen for the public sector and commercial fleets here in the US. So I've got a lot of experience here in the battery storage. At Sierra Nevada, that is, they had the existing solar, which I worked on when I was at SunPower. So I helped them install the EV charging with Tesla. And then we replaced some of their old cogen units and added in microturbines and battery storage for them to run at that facility. They weren't quite ready to do a full microgrid, but that was on the roadmap, and all that equipment is microgrid capable. So I'm glad you got to see some of our technology in action and how it works, because they're an impressive group and an exciting group to be a part of. So why don't we move on to the next slide here and give you a little bit about today's agenda and what I'm trying to focus on. And for those of you who have questions, you can either use the chat function or you can just stop me and or put up your hand and let me know, and I will address those questions. So, but the focus for today really is around how battery storage can help in energy resiliency, some of the impact that these disruptions have, and where we're seeing more of a focus of installing either backup power or microgrids. What really goes on in the planning phase and how you're actually doing that with the roadmap. And I'll follow up with a couple of case studies to give you some ideas on how it worked, some of the challenges, and what went well. So I will keep moving along here, and we'll go to the next slide. I'm going to give you one slide on Engie. Engie is one of the largest energy companies in the world. We have about $65 billion in revenue, about almost now $100 billion in assets that we manage and run. We have been doing everything across the board. About 3 years ago, Engie made a decision to sell all of its coal and natural gas plants and convert them into clean renewable energy. So we have been growing our solar, wind, battery storage, EV charging infrastructure across the world, and I'm pretty impressed with what they've done from a leadership perspective in energy. You can read a lot more about Engie, and that's my real only discussion about that, but at least it gives you a little background about what we do. So why don't we go to the next slide? And I do think it's important to talk about what resiliency is versus backup power, because I see them differently, or at least a microgrid to resiliency to backup power. The way I see resiliency is kind of either one of those two solutions. And how I differentiate a microgrid from backup power is a microgrid has usually 2 generation sources, where backup power usually only has 1. So I see solar and storage being a backup power solution. It's a lot less complicated and requires less software and requirements than a backup power solution, which usually is 2 generation sources and a storage component to that. So just to give you an idea of how I see the two differently and what's there. This is the actual definition of resiliency from the Department of Defense, which I can let you read. But why are we seeing more of this now? And if I look over the last, I would say 7 to 8 years of adding, energy storage and backup power solutions to public and private sector, I think I've seen more activity in the last year than I've seen in the first 7. And it's primarily because I think a number of the outages that we've seen, you've got a number of storms, you had the wildfires here in California, and that has really prompted many entities to look at backup power. And it's still interesting to me about how many people think, well, if I have solar on my roof, then I can just do backup power. Like, why doesn't it run when when the grid goes down? And so there's a lot of education that needs to be put out there around what and how you need in order to run your facility or run a portion of your facility when the grid goes down. And the nice thing is you're starting to see a lot more funding, especially here in California, to support this. I'll talk a little bit more about that later, but it's definitely an area that is growing, and we're seeing a lot more requirements put into that. And the industry, I think, is still a little bit young on the microgrid side. So there's a lot of opportunity for smart people like you guys to come in and help the industry evolve quickly and really develop more turnkey solutions. With that, we'll go on to the next slide. So let's keep going one more. So why are we seeing some of this? And I focused a little bit here up on PG&E since you're here mainly in Northern California, but there have been quite a few public power shutoffs, and that is something that I think we are just going to have to live with as we go forward. Our climate is getting drier, the causes have gone up, and more utilities are seeing this as a requirement to run their business and to limit the amount of litigation that they have when these events happen. So I think you're going to see more, not less of these. There is not a lot of the challenge to fix some of the infrastructure within PG&E is decades. So this is not going to be, there's no short-term fix that we see on the horizon to address this, especially with PG&E bankruptcy and other issues that are happening there. We're seeing more and more need for the private sector to step up and help provide solutions to support this environment. So I'll keep moving along here. So most people don't realize how often we are getting these, just if you look at the last part of last year, how many outages did PG&E have and what the impact was. Really October is where I think most people felt it, where they had, in one outage over 730 people impacted and another outage almost 1 million. And when you start seeing these scale of impacts, you're seeing more and more cities, counties, entities looking for solutions. And like I said, it's pretty staggering when you see, how many counties, when you look at 38 counties in California that were impacted and the bulk of those being in Northern California, I think that we really need to help bring solutions to the market. So I'm going to keep going along here. And maybe I'm preaching to the choir, but there's a lot of impacts to this. I mean, as you saw, people that didn't have power for weeks, it really created an issue for them just from a physical health perspective, a mental health perspective, a lot of lost revenue for stores and businesses and manufacturers. Also, when your schools are shut down and your parents work, what do you do with the kids? You know, these are a lot of the underlying things that we started to see in these impacts, as well as just without any electrical infrastructure, we saw a higher rate of burglaries and thefts that were occurring. So this is much broader than just, hey, the power went out and my fridge doesn't work. We're seeing a bigger impact across all society and what that impact has on people, on businesses, on revenue, on lost profits. So it's becoming more and more of a challenge. And I think that's one of the areas that most people really struggle with is what is the true cost if your power goes out for a day or a week? Because there's a lot of factors that are included there that may not be counted in your initial assessment. So let's go on to the next slide here. I talked about most of this here, but many times in different entities, when they have an outage, you're seeing the impact on IT and communication equipment that are, I think we got someone who might need to go on mute. And you might be able to see them, Nishant, and mute them. They may not know they're getting all the background noise. But it has a number of other of impacts, and we're starting to see more and more growth around emergency shelters. I'm working with a lot of schools to help power a gym with HVAC as a remote emergency shelter. And also, I think lastly, really on customer satisfaction. You know, when customers are relying on your orders and your power goes down, and you know, I've got one customer, which is they do quartz manufacturing. So they do a lot of the quartz for not just watches, but for a lot of industrial machines. And when the grid goes down for an hour, it costs them over $1 million in lost revenue. And it's not just the production delay, but when these go down in the process, the material freezes inside of their manufacturing process, and just to disassemble and get those new parts and put them back in is a 2 to 3 week process. So it's not just the day delay or the hour delay, it's they've now backlogged almost a month of material, and that has a much bigger impact to their customers. So these are some of the downstream impacts that we're seeing with when the grid goes out. I will go on to the next slide. And let's talk a little bit about what we should consider as part of this whole process. So many times now we're getting customers who I think are frustrated with the grid outages and are trying to come up with solutions. And they don't, like I said earlier, really understand what does it mean to create a microgrid or install battery storage and resiliency. So I think a lot of that comes down to the beginning of what is that impact, what is their financial you know, the cost of the grid goes down, and you know, what is the happiness within their employees and their customers. And so we're starting to see more and more clients that are doing resiliency with less than financially attractive, you know, I'd say requirements, because I think it's pretty easy if you're losing $1 million an hour to come up with a backup power solution. But if you're a school or a city office that goes down for an hour, it really doesn't have that much of an impact other than people not being able to provide services. But customers are requiring more and more that you be open, and so they do want to have that. I think we're also starting to see more and more people with some of the frustrations with utilities want to have energy independence. And so I'm seeing a stronger need for off-grid. I'll give you an example where you've got the county of Santa Barbara, and the SCE came in last year and said, we've got this large line coming into that whole peninsula, and we know it's going to go out, and you're going to lose almost 60% of the generation for this whole area. And so we are prioritizing who gets energy and who doesn't. But basically plan on your city offices not having power for over a month to maybe 2 months. And that kind of discussion, I think, really prompted them to build an infrastructure that if the grid goes down and they lose that line, they can literally deconnect from SCE and connect into their solar and battery storage and microgrid system and run their offices as a micro utility within their county. And it's these types of solutions that are coming in that I think are really interesting. And is that a question? Nope. Okay. And I think some of the challenges that they're facing is what they want to do and the technology options that are there. The technology hasn't caught up yet with what are some of the requirements that people are looking for. And so I really think this whole design process needs to look at the impacts here and what is available, what do we need, and then how do we get to that optimal solution. So I'm going to pause for a second and see if there are any questions that I can help address at this point before we go on. If you're talking, you're muted.
Hey, Steve, question here. When you first started, you kind of went through quickly resiliency, microgrid, backup power, and you tried to differentiate. The microgrid, you said it had 2 generation sources. The backup power had 2 generation sources and storage. And I thought that was more resiliency because that had 2 generations and storage as well, I thought. So now I'm kind of, just want to make sure I had it right.
Well, I may have confused you, so let me take a step back on that. So I see energy resiliency as any form of power when the grid goes down. So that's kind of this overall umbrella. I see backup power as battery storage with a single generator.
Okay.
And I see microgrid as 2 generation assets and battery storage, or a type of storage. There's different types of storage you can use.
Just energy storage, got it. Okay. I thought I had it right, and when you started talking, somehow I messed up my notes. So, okay, thanks.
Yeah, and I think the real challenge is a microgrid controller needs to manage different generation resources and balance them, where when you have backup power, like I have backup power here at my house, and really it works great. You know, the grid goes down, whatever's running is now being run on the battery for whatever duration of battery I have. It's a simple system, but it works. It doesn't curtail any load. If I'm going to run out of power, I can manually go run around and turn things off. But to me, that's kind of a backup power solution. Whereas a microgrid, if I had, let's say, a fuel cell here, or I had a diesel generator, I could now balance between the battery storage, the diesel generator, and the building load. And now, as you're seeing smarter and smarter microgrids to come in, you can do a manual or automated control system with the energy management system on site, and you can really start balancing this to get an optimal use of what generation assets you have, what solar is being produced, and what are critical functions within the facility that can be powered during that outage. Does that help?
Yes, yeah.
Great, thank you for the question. I see a question in the chat. Oops, sorry.
I was just going to direct your attention to that chat question.
Great. So the question is, who owns the wires in a microgrid? So I will come and show you a single line a little bit later on in a microgrid, but typically the microgrid starts on the customer side of the meter, and that is owned by the customer, or if it is a finance solution where a third-party financier is installing battery storage, solar, and another generation asset, then the financier owns whatever is installed that supports that microgrid. So typically they don't own the conduit in the building, but they would own the conduit from the solar system to the battery storage system to the microgrid controller to wherever that ties into the main meter. So, great question. All right, let's keep moving along here. Up. Do I see customers? There's another question here which I will bring up, and which is, do I see customers putting in a microgrid and then coordinating dispatch of the resources to take financial advantage of different power rates? Absolutely. I will talk about this a little bit later on of really what are the additional revenue streams the battery storage can do when the grid is operating. When the grid is not operating, there are no value or revenue streams or different rate structures to take part of because the grid isn't operating. But while the grid is operating, we always have a discussion with the client of how much power do you keep as backup? How much of that battery storage do you want to use to lower peak demand, to do energy arbitrage, to offset, high time usage? And so there absolutely is a way to do that, and it improves the financial metrics of the project. So I'm going to keep moving to the next slide here because I think I've talked a lot about this. And it kind of handles the question that I was just talking here, which is, how do you size how much to back up? Because it would be great to say, I want a solution that is going to manage the entire campus for a week or run the entire campus for a week. Well, the problem with that is that could be $20 to $40 million in energy storage, which is not financially attractive. So it's really a balance of, first of all, what is the critical load panel you want to create within that building to be able to power certain parts of that building? Because typically you do not need everything. I have a Kaiser facility up in Santa Rosa, which is an all-electric building. It has a 680 kilowatt solar system. And the key thing for them is to be able to manage 2 hours of lighting in the facility, cooling in their refrigerators, because they have medicines that if the fridge goes down for more than 30 minutes, they have to actually pick up that medicine and move it to a Roanoke Park facility. So we have to power the refrigeration units in there. But we also need to proceed to power the procedure rooms. Because if you're in the middle of stitching someone up and the grid goes down, you at least want to finish stitching them up with some lights and tools. So part of that whole design of how do you and what do you want is an interesting collaboration between the doctors, staff, security, and the cost of how much storage you're putting in. So I think it's a critical discussion to have up front, because not everybody's going to be happy. Right? Someone's going to not get their AC unit, and they're not going to be happy that they may be working in 72-degree offices. But to spend an extra $500,000 to get an hour worth of AC, most people don't go that route. So I think this is really a key question you have to look at with your clients is, what do you want to back up for how long? And what's the must-have versus the nice-have? So it's a good question that's based on the other one. All right, it looks like I have another question here of saying, how would I classify CHP? Ideally, it's designed to operate 100% in parallel with the grid. Yep. So most of the CHP, yes, they would be running in parallel. And the question is, if the grid goes down, obviously you would have to put in switchgear and other infrastructure to be able to run that with the building. And typically we would look at that as more of a base load, and then the battery storage could be handling the spikes that are happening within the building, that we could then provide a higher level of backup power to more resources, because most resources don't look like base load. Let me make sure I understand your question right. I think I addressed that, which is, yeah, when the grid is not down.
It did, Steve. Oh, hi, this is Jameson. Actually, I'm actually out in New Jersey. I just found out about this on a forum, and I decided to join in because I actually do a fair amount of work with designing CHP systems. 1 megawatt system put in Times Square, and working on a much smaller system. It's only 100 kW, but it's for Meals on Wheels. I've heard of them. You know, and basically it has to have full operate independent from the grid during like a, you know, another Hurricane Sandy type situation, right? And pretty much the, you know, it would operate independently from the grid anyways, in normal conditions, which is like a single pipe of gas coming in. Now, I guess the only other question I got for you regarding this is, with the controllers, can also do thermal dispatching as well in some of them, so you can make sure you use the most amount of waste heat coming off the plant. So overall, from let's say, you know, source energy, you're at like, you know, the best that you can be or something like that.
Yeah, it really is how you design that system, right? And what entities within the facility do you want to power during an outage? So you could do both electric and thermal if that's what you needed. I'm not aware of any reason why you couldn't, other than the limitation on the additional energy for thermal, and do you have enough to manage it? But if you're already running this plant at 100% efficiency for the most part, I mean, running the plant 100% with the CHP, the only question would be is during an outage, if they had a reduced load and you've got to reduce the CHP output, you need a place to put that power. So you could be running a balance of energy storage to push that back in and increase the efficiency, but you're going to need a controller that's going to have to. We typically don't see CHPs just with a microgrid controller, because the ramping up and down of it isn't fast enough, and also impacts, you know, it can trip the CHP and then you shut down the whole plant. So we typically tie it with battery storage, so we can either take power to increase the efficiency or put power out of the batteries to mitigate some of those spikes in energy usage on the facility. Does that help?
Oh, it actually does. I may want to chat with you a little bit more because I have some interesting technical questions I wanted to pick your brain on for this project. Like, you know, what kind of bus we should put all the generators in. Should we convert it into DC and then back to AC again so we get nice, smooth power? I mean, I don't know. You know, it's like.
Yep. Well, why don't we talk afterwards, or my contact information's on the slide, and we can go through your specific example later on.
Sure. Thank you so much.
Sure. All right, let's go on to the next slide here. I'll keep this moving. I think I talked a good chunk about this already, and this happens to be one for a school district that we're working with, but it really is significantly more expensive to run multiple weeks for an entire campus. So I think you get the additional cost versus the ROI. What we're typically seeing on most facilities is we're using about 50% of the batteries as backup power, and the other 50% of the batteries to do peak demand shaving or arbitrage or other utility services to make the project look more financially attractive. Many of the funding sources that we get here in California, the California SCHIP, we cannot be 100% dedicated to backup power. So because we have to cycle and discharge the batteries as part of the incentive. So we do multiple services with that, which improve the financial ROI. One of the nice things that most smart battery storage providers will be able to offer is basically a storm watch solution, where if there is a higher, let's say if we know it's an alert from PG&E that the grid has a high potential to go down, we will start moving that from a 50-50 ratio to maybe an 80-20 or 100%, 0%, where the 100% is for backup power during that event. Or if there's a large storm on the East Coast coming in, we may adjust that as well. So we keep more backup power in the batteries for outages. And then once that storm's passed or the outage is passed, we'll go back to our original calculations. So there is some flexibility designed into that. So let's go on to the next slide here. So if you take a look at some of the trade-offs here between the different types of generation assets, what are the pros and cons, right? So a diesel generator is the most common backup power solution today. It can run into perpetuity as long as you have enough fuel. It is the lowest cost. It is getting harder and harder to install diesel generators with air quality management for non-critical facilities. And so it's an area that people from the CO2 offsets are trying to figure out different alternatives to. If you look at natural gas generators, those also are becoming more and more common, especially in the residential sector and small commercial. One of the challenges we saw, though, up here in Northern California is PG&E also shut off the gas lines as part of the outages. So that became a problem when you were running your backup power when the electricity went down, and they also shut the gas off. So you have to be a little bit careful on that to make sure that the utility is allowing that, or you do have natural gas in your area to be able to do that. But it is a more efficient, longer duration solution if you have access to the gas. The solar and storage, or wind and storage, is one that's definitely got a lot more attention lately. And with some of the new SCHIP that just opened up in the beginning of this month, it was really paying for about 100% of the battery storage. So it became very attractive on the ROI. But without incentives, it is one of the lower. The ROI is not as attractive as it is without an incentive. But if you size the system right, you really are able to run that system of solar and storage for whatever duration you have. If you've got enough space to put the solar, you could really run that facility into perpetuity. But most people don't have enough space to run that, to put up a solar and storage system. So we typically see weeks, usually 1 to 2 weeks of where you can run the two, or if it's in winter where you're getting less solar production, and there's not enough production to be able to create enough energy to run that facility. Now the microgrid, like I said, is really combining two of those. And our most common right now is putting in a diesel generator or natural gas generator with solar and storage. And it's really the balancing of which asset do you use and when, because you want to run the diesel and natural gas generators at a higher efficiency, or it could be a microturbine, it could be other things, or a fuel cell, to really be able to have that as the base load. And then the solar and storage is being used to offset the spikes, or when the solar is producing those valleys. The other challenge I think about this right now in microgrids is there really aren't off the shelf solutions you can plug and play. It seems like every single microgrid we do is a one-off solution these days. And so it gets tough when you're building snowflakes, you know, and you want something that's just turnkey. I think the market's getting there. We're starting to see some better solutions that are coming into the market, but it's just not there yet, because it is a more complicated approach when you start looking at how do you reduce load in the building. One of the things that I think is traditionally you would set up a critical load panel and you would hardwire everything into that building. What we're seeing now in some of our newest microgrids is we're putting the ability to curtail load as part of when the grid goes down, and we're doing it through controls. So you can put smart controllers within the building and start shedding load, and then you can just power up. You don't have to go rewire the entire building for a critical load panel. And I'll give you an example that I mentioned the Kaiser facility up in Santa Rosa. This is a brand new all-electric building, 4 floors. And to power what we needed to power was going to cost them, the total project cost of the storage in the microgrid was about $800,000. Pre-incentive. With the incentive, their net outage was about $400,000. The rewiring cost of the building just to put a critical load panel in to service the lighting, the refrigeration, and the patient rooms was $850,000. So you're like, you know, that's more than the whole battery storage and microgrid solution there. Yeah. And so what we did is we said, since you do have smart controls, let's focus on curtailing load and having a grid down operation within the building, and that cost about $120,000. So we see more and more, we hope that we'll see more and more of that in the design as you're designing buildings to really curtail load versus rewire. And so I would start thinking of that as you're building buildings and new construction, to start making them microgrid ready. And it's a much more cost-effective solution. So why don't I go on to the next slide, and then we'll answer some questions here. So I think we've talked a lot about the feasibility. Here's a number of things that we look at as we are starting to look at the loads and what to look at in our analysis. Most of these, you know. The one thing I'm seeing a lot of growth on here is electric fleets, whether these are electric buses, school buses, you know, short haul trucking, distribution, forklifts, even their own employee parking. I'm seeing that as a big consideration of adding backup power to it in order to them to operate, especially if they're part of the first responders. So you can kind of read through these, what we're looking at and what to pay attention to here. And I'll take a second here to see if we have any other questions on a lot of the stuff we just tackled.
Yeah, can you hear, am I muted?
Nope, we can hear you.
So the idea of adding the critical load panel sounds like in a retrofit situation that's not financially feasible, but if you're designing new construction, then it wouldn't be as much. That would be a better option moving forward. It sounds like, if you plan for the microgrid ready solution.
Definitely, it is. Not all retrofits of a critical load panel, it all depends on how they're wired, right? If someone wired all the lighting into the panel into a single panel and we can just power that panel, that's very easy. But what happens is when you start finding that the lighting, for example, is in 7 different panels, and now you've got to rewire all 7 of those and rerun or pull those wires into a new panel, that's where it starts getting expensive.
Okay.
Yeah, we're starting to see even, and I'll stay with Kaiser, all of their new building designs are incorporating microgrids as part of that design. And they're putting space in for where the battery storage would go, where the solar's going, their electrical wiring infrastructure. And so I think they're planning for that, whether they do it as part of the design or whether they do it as part of the initial installation or the secondary or later on. They're building those facilities with it in mind. Sean, good question, which is saying, are some designs leveraging the power of energy stored in EVs? We are seeing that in vehicle to grid as part of an initial design. We have not done a vehicle to grid project that is active today. I'm seeing more and more of that in transportation and public schools, where they want the ability to use the batteries in those buses as part of either the grid outage or as part of creating more revenue with utility services. Most of that's very early though, and it is not yet, I would say, ready for prime time. So we're really starting to look at the original early pilots in that. But it is definitely an option, and I think something in the future. It will be a balance of how much do you derate the batteries in the buses by using them for these other services versus the benefits to that facility. The other thing, which is probably a whole nother conversation on that, is the second life batteries coming out of those buses. Where do they go? And can you start transferring them to on-site battery storage as part of their transition when they can no longer operate the routes because they've derated? So great topic for maybe a future conversation. Let's go on to the next slide. I need to keep moving through some of these pretty quickly here, which kind of ties into the one that you just mentioned here, which are what are some of the other revenue streams that you can do with battery storage or a microgrid when it's not in a grid outage situation. So most of what we do today in California are behind the meter solutions. So we do peak demand shaving, which is usually the most attractive. We will do energy arbitrage. We're seeing more and more of utilities wanting local RA, resource adequacy. So we can keep capacity, we can participate in their DRAM or DR program, and we can provide energy when the utility needs it. So I'll give you an example we have here in the Bay Area. Is we did a partnership with PG&E where we deployed a number of battery storage systems, and in the summer months, we aggregate all of these loads across the San Jose area, and PG&E asks us from 4:30 to 6, what can you give me? And we will tell them day in advance, an hour in advance, of how much power we can deliver to them and where on that grid. And they pay the customers for that benefit. And so then they will call on our batteries, and we will then dispatch energy to support that in real time when they need it for usually an hour to 2. And so that is a really exciting way for the customer to get more benefit. The utility gets more benefit, and it's not impacting their operation because it's all excess capacity that we have built into those systems. And sometimes it's customer A, sometimes it's customer B, sometimes it's A, B, C, and D. It just depends on what we're predicting them not to need for that particular time frame. So it's a pretty exciting benefit, and one that will continue to expand. Outside of California, we are able to use batteries to participate in front of the meter or wholesale services. So on the East Coast, I am doing cap tag reduction, frequency, volt VAR, load shifting for the utility or the ISO, and getting a much bigger revenue stream for those services. We are not allowed to do that in Cal ISO today, but that will, I think, come over the next few years, and will make those batteries produce more revenue than what we do today. So let's move on to the next slide here. So a lot of people ask me, well, how do you size these? What do they look like, right? So in our commercial world, we're typically deploying modular units starting off at about 120 kilowatts to 240 kilowatt hours, up to about a 1 megawatt, 2 megawatt hour system. So those are the containerized systems that you see there on the left. That's a 250, 500 kilowatt hour system. The ones in the middle are containerized solutions. So they tend to start off, 40-foot container holds a 1 megawatt, 2 megawatt hour, and we're starting to see more density where you're getting a 1 megawatt, 3.5 megawatt hour system in a 40-foot container. But typically we do containers up to about a 10 megawatt, 20 megawatt hour system. Once we get above that, we literally build a building, and we do a steel construction building. We put all the batteries inside, we put conditioned air, and we put the inverters outside. And it's just more economical to build. You know, we've got a 480 kilowatt hour system we're building on Hawaii that we were just awarded. We've got a very large project in LA that's about a 600 kilowatt hour system. Those are all, you know, built with buildings that we're creating on site. We obviously work with a lot of different technology players in the market. We still do Tesla. Some of their supply constraints. I think when you look at which technology to choose, I think it depends on a couple things, not just cost. It depends on the chemistry that's being used. So some of our high desert or high heat environments, we tend to go lithium iron phosphate. So we do a BYD system because it performs better in high heat. If we are, you know, if it's not a high heat situation and it's standard usage, we may go Samsung or Tesla, which tend to have better density and perform better in those more less volatile environments. And so it does vary a little bit on the chemistry you choose based on the utilization and what is the load and how you're using the batteries. So with the kind of hardware and with some of the revenue streams I talk about, why don't I take a moment for questions here? I was hearing you guys are not a quiet group, so I'm surprised.
Well, I have a question. So my question is like for long-term storage, like seasonal variation, like are you seeing some chemistries which are coming up and some adoption which is actually happening? And if yes, where exactly is that?
Sure. I had high hopes on flow batteries and other types of long duration batteries. The challenge is many of these are still really in their early stages and are not financeable. So you're starting to see a couple that have been installed with grants, and we're starting to get some of the early test data from those. The key question is, just with the drop in lithium ion pricing over the last 2 years, which is almost over a 50% cost reduction, can they scale fast enough to compete with long duration lithium ion? And that's just, we don't know. When costs were, if I look at anything in the 2 megawatt and above category, an installed system per megawatt hour, you're looking about I'd say high 300s to low $400 per kilowatt hour capacity to have it installed. If I looked at that 2 years ago, that was over $1,000. So you're starting to see a lot of the costs come down and become more economical, which I think is going to be a challenge for the long duration batteries. But they also have less maintenance and the D rates can be lower. So I'm hoping those benefits can offset the cost and the financeability of those, and we see more pilots get in and they gain traction.
Thank you.
Sure. Let's go to the next slide. Let me go to a couple case studies here. So this is our longest operating backup power solution, which is now in year 6, if I remember correctly. So a very early microgrid that we installed here in the Bay Area. They had existing 12 megawatts of diesel generators that were running backup power. They had some intermittency with those. They had some reliability issues. They were looking to downsize those. And so they really wanted to install a microgrid that ran solar PV, fuel cells, battery storage, and could help complement the diesel generator backups. So this was very much one of the really early microgrids. So almost everything we did, we had to custom build outside of the PV and the battery storage system. And all the controls were first generation controls. But we're using those to reduce their electric spend and reduce peak demand shaving. And so between the solar, the storage, and the wind, there's a very large wind system that was installed there as well. Or I'm sorry, not a very large wind system. It's only 2.3 kilowatts. But they wanted to test that for later if they want to put in bigger turbines. And so when you're managing 4 different generators and tying it into an existing generation system, and I think there was a question earlier about of thermal. We did not tie it into the hot water, but we did some renovations and reduced electricity. So by combining all of the solar storage, fuel cell, batteries, and a small turbine, we knocked their energy spend down about 70%. We also did some retrofits within the facility around the water, which is why you're seeing that, and sewage. But this is a pretty, we learned a lot on this. And I can't say it went perfectly because a lot of things we thought would work, we found out it didn't work, especially around the controls and how to balance load. So we had to come back and reconstruct a number of things on the site. But it took us probably 6 months longer than we thought. But once we got it stable, this has been working great. And it's one of the earlier ones that are out there. And it was a great first project for us to figure out how to do. And we learned a lot from that. Why don't we go to the next slide? You fast forward to a recent one that we installed last year, and this happens to be on the East Coast, where this is a large solar system installed with a 3 megawatt, 6 megawatt hour battery storage system. And it is managing, on the East Coast, they have something called, the ISO has coincident peak days. And your demand is set based on 5 peaks of the grid for that year. So even if you're not doing anything, it's not one of your peak days, whatever you did that day, or the highest coincidental peak for the year, sets your demand charge for the year. So you really want to use these battery storage systems in the solar to reduce those coincidental peaks from the ISO, but also do solar firming frequency, capacity bidding into the ISO, and peak demand shaving. So this is where we're able to do in front of the meter and behind the grid. In the phase that this has now been running for over a year, they did not elect to do a backup power, so we made it all backup power ready, but our plan is later this year to be able to run some of the local town on this grid. And what we're missing is the connection and the downstream relays from this facility to the town, and being able to decouple the town so none of the linemen get injured. But once that's in place, we'll be able to run the town on this solution. So it's kind of an interesting way to manage that. Why don't we go to the next slide? So this is one that's just being built up in just outside of Humboldt County in Northern California. It's the Redwood Coast Airport. There's quite a few different players up here, but thinking you may want to see something a little more technical, I thought I'd throw in a single line, or a one line, I should say. And just to help you better understand, I think, what are the different reclosures, circuit breakers, what you have to disconnect, what the microgrid's going to manage. So in this particular case, this is really managing just solar, two different solar systems, battery storage and EV charging. And there's a number of downstream buildings. There's the main airport, there's an air station, there's 15 other meters on the facility that we'll be managing, as well as EV charging for buses and transportation on the site. But you can see the microgrid controller will disconnect from the grid, and then it will manage all of this power. Now, the battery storage system, which is 8.8 megawatt hours, and the solar, which is 2.2 megawatts, isn't enough to manage this entire load. So part of what the microgrid controller will be doing is lowering or reducing the load on some of these existing, on the load centers, and prioritizing those. So if it happens to be in winter where we're not getting a lot of solar, and it happens to be a morning outage where the battery storage isn't fully charged, we're going to have to curtail more of the load than we normally would. If it was in summer, in let's say the afternoon, the batteries are fully charged, the solar's cranking, we wouldn't have to curtail any load. So really, as part of your design, we had to make some trade-offs, because we couldn't afford to put in they couldn't afford, I should say, to put in a bigger battery storage system to make it 100% full utilization year round. So I'll pause for a second here. I thought I heard a question.
This is Sean. I have a question. Can you hear me?
Yep, we can hear you.
All right, cool. I think that up in that region, they are exposed to the power shutoff, or the public safety power shutoff. And I could see that a solution like this could help offset that. However, obviously there's a lot of variables. It sounds like they didn't size the system sufficiently to be able to deal with the PSPS. Is that a correct opinion or statement or assessment?
Well, part of it was the budget. Part of it was this is funded by a CEC grant, and the grant would only pay for $5 million, and they had to come up with the rest. And this is about a $12 million project. So their budget limited what they could do. And so that was the main reason of why it will not be 100%. But they also felt that some of the things on, some of the storage areas of the facilities on the airport, they could curtail load on and would not have a significant impact. The other thing they looked at is rotating air conditioning, so they could cycle the time between when the air handlers turn on longer, increase the air temperature, 2 to 4 degrees, and be able to curtail some of that load that way, where people could still operate and perform in those buildings, but it just wouldn't be as comfortable as it normally would. So, these are some of the trade-offs in the design I think you have to make to figure this out.
Okay, thanks.
Any other questions on some of the examples? Or
this is Nat. So on this the example you gave where they had to curtail to some extent, depending on the time of year, I could see on the HVAC side, they could do, raise the temperature, and that would lower the energy use of the equipment. But it's like that's similar to like an ADR event. But what triggers that? Would it be the fact that PG&E went offline, and then the microgrid controller would have a protocol to then do that, depending on the battery storage level?
Exactly. So what you do is you program into the microgrid controller grid outage situations, and the reason why in the winter is there isn't enough solar production, and so you're having to rely on either the grid to charge the batteries. And the example I gave in the morning is where the battery storage usually would be at its lowest level because it's expecting the PV to turn on and repower it. And so in those scenarios, if you don't oversize the battery, you're hoping that the PV would have, recharged those batteries. So as a default, you say, okay, if this worst case scenario happens, what can we curtail? And it may only be a month out of the year. Now, the nice thing is in winter, you're probably not running air conditioning. You're probably running electric heat, right? And because up there they don't have, actually they may have gas up there. If you go farther up, I know they don't have gas. They only have electric. So now the question is, heating, do you do it? Or you may have, the welding shop on the airport that you have to say, hey, look, on a grid down outage, we're not letting you operate that equipment, right? So it may be a process you stop that's not critical.
So, okay, so the next question is then on, I know it's really important to have the controller because that does everything, but do all controllers for microgrid setup like this have the ability to do something with curtailing load? Or I thought it was just switching between battery and PV and the generator, and also anticipating that, okay, we're getting a signal, power is going to drop, so they're going to switch over so that no one downstream even knows there was a power outage. I didn't realize that they could do the curtailment as well on equipment. Is that common, or is that a special feature you have to look for?
That's a newer, more sophisticated microgrid controller. Most microgrid controllers will just balance whatever is coming in between the two generators, and they'll just send it to whatever is being consumed in the building or in the critical load panel.
Okay. Huh.
Or what a lot of people do, unfortunately, is they have manual overrides, right? Grid goes down, and they're like, okay, we're going to need to run this for a couple hours. We need to manually go shut stuff off. And the more they shut off, the longer their batteries can go.
Okay.
But I am seeing more and more where the microgrid controller connected into the energy management system, or putting disconnects on lines downstream, gives them the ability to curtail or shut off load.
Great, thanks.
Sure. Yeah, I'm excited that I think this is an area that, with, if you look over the next few years coming up, you'll see more inventions coming in, more technology that makes these buildings a lot smarter and gives us a lot more flexibility of what we can and can't do.
Steve, as part of the implementation, did you install VFDs so you can soft start some of your equipment? Instead of just putting the AC on, right at the beginning, right when at the beginning, maybe ramp the fan up, maybe ramp the compressors up, things like that. Was that part of the implementation as well?
We have this one right here I'm talking about has not been installed yet, but on some of the specialized equipment, and especially where we're in manufacturing, it depends on what the ride-through is. So this is actually an important factor that I didn't talk about. Many also people, what you have to look at is is how fast does that electricity need to come back on, not to, you know, basically turn the equipment off. It depends on the customer, right? So if you have, like in Kaiser's situation, if that power from the microgrid doesn't restart for 1.5 seconds, not a big deal, right? Because the lights flicker off, they come back on. The refrigerators, it's not an impact, they don't care, right? But if you have specialized equipment that shuts off in milliseconds, then you have to have a solution that allows for that ride through to basically not shut down key equipment. The case I mentioned to you about the quartz manufacturer, if we were over 300 milliseconds, that equipment would shut down and cause a problem. So you have to have a UPS system for that ride through for a certain period of time that would allow that equipment to continue to run while you switch up for power, you disconnect from the grid, and then you repower with the batteries. Your question was more around on restarting the equipment. How do you make sure that you don't create, you know, you can ramp that up slowly or whatever is required not to damage the equipment? And yes, you do want to you do want to look at that to make sure, what is the ride through? Is it seamless? Or if it's not seamless and it shuts down for let's say 2 seconds, do you need to have, you know, a complete restart of that equipment with ramping capability or not? Did that answer your question?
Yeah, it does. Yeah.
Good question. And thank you. I forgot to bring up the point about how long does your equipment need to, does it need not to trip, and what's that impact going to be? Because that's an important calculation on any solution. All right, I will move on to the next slide here, which we'll keep going. So I think, you know, we talked a lot about this as part of the questions, but really, what do you want to look at? How integrated do you want your solution to be? How flexible do you want it to be? We talked a little bit about some of the advanced controls and the ability for the microgrid controller and the energy management system to be more intelligent versus, you know, kind of dumber and hardwired. And I think I have not seen an end-to-end complete solution from one provider. It's a piecemeal of different technologies. And so I think it is important to really look at best-of-breed technologies for a specific solution, because it does vary depending on the usage and the climate and what's being installed there, and how you package these together. There is quite a bit of money right now available in grants and some specialized grants through the CEC and other utilities. So pay attention to those, because like I said, the SGIP resiliency budget paid over $1 per kilowatt, which meant you're getting batteries for free. So you want to see those. And then you want to be able to tie it with a battery storage provider that has intelligent software that can predict and how to drive more revenue. Because in some of these systems, you know, without funding, we're getting a 3 to 4 year payback. And with the incentives, you're basically getting a first-year payback. So they can be very attractive. Why don't I go to the next slide? So this is kind of a decision tree we tend to go through a lot, which is a basic one, I think, to help you say, you know, hey, I would like backup power. Great. You know, what do you want to back up? You know, the whole building? Do you have identified critical loads? How is it wired? And really kind of going through that evaluation. If I say, yeah, I do want to do the whole building, then the question is, do you want to do diesel, natural gas? Do you want to do renewable? What are the benefits? And then you really start getting a little bit more into the details that we've talked about. Many people like, I think, a clean solution or air quality managed will limit what diesel generators you can put in, so you're forced down a different route. And the other key thing is, you know, do I have space for solar and storage? Is it cost effective? Is it enough to power what I need? So all these, I think, are important questions that we've kind of talked about, but we tend to build, and this goes much deeper as you go down in a decision tree with our clients and help them walk that through as part of an initial assessment for backup power. So I wanted to give you a little bit of a taste of what that looked like and how you can start thinking about it. But many of the topics we talked about today, I think you could build your own decision trees around what's important, what do I offer, and typically we get stuck where we'll start building a solution and then the customer comes back saying, no, you know, Betsy from IT really wants this added now, right? And so your scope creep tends to get bigger as more people find out that this is an option going in, and then you have to rework a lot of your stuff. So try and get as many stakeholders in as possible, and many times the customer doesn't know. You know, they don't know, and it happens on them. So they think they've covered their bases, but they haven't. All right, I'll go with the next slide. Oh, I talked about some of these already. Sorry, I'm getting myself ahead of myself here.
Steve, this is Sean.
Hey, Sean.
Hey, just a quick question about the scope creep. I'm a consultant myself, so you have to renegotiate if they're trying to throw extra things at you when you already sort of negotiated scope and cost, right?
Yeah, and it depends on what it is, right? If it's within, you know, what we currently had budgeted and see, then yes. But typically, we're adding more capacity to the batteries, which is an additional cost, or rewiring of those circuits to get them included as part of the design.
Right. So it either impacts budget or scope. Kind of. Yeah. Got it.
Sure. I think one of the other things that many of these I've already touched on, but if you're already doing existing upgrades or modernization plans, that's a great time to look at adding a microgrid, because you're already on site, you're already doing construction. You know, I'll tell you how many projects just frustrates me where a year and a half ago they ripped up a bunch of work because they didn't think about putting new conduit in, and we're out there ripping up stuff they just did, where if they would have added, I mean, new conduit in a trench is dirt cheap, right? And so if you think it may happen, add it, because it pays off a ton. That's always frustrating. You know, the other key things I think here is when you really look at your partners and vendors, make sure they've done something similar. You really, I don't think, want to be their test case. And ask a lot of questions. Why did you choose that technology? Why are you doing it this way? What are the alternatives? Because if they haven't done a lot of these, I think they just take the same one and try and do it again. It's a one size fits all, which may not be the best solution for your particular, you know, situation. And the last thing I do want to stay more and more on is funding opportunities are out there. There are going to be more coming. There's a lot of mindset within the California state government right now, the PUC and the CEC, which drives that, and EPIC funding to test out microgrids. So there's a lot of smart people out there that want to do this. Pay attention to those, because it really does help offset the costs. All right, I'll go to the next slide, which I think is questions. I know you've asked a lot along the way, but I tried to move through this, and I think I'm getting close there. I can't remember when I was supposed to be done by, but it's been a great, you know, discussion, and I want to encourage you to continue to ask questions here, because this is new and not everybody has the answers.
So in the previous slide, this is Nishant. So I had a question regarding like financing. So have you seen scenarios where, you know, accelerated depreciation is part of the equation as well? And if yes, you know, what is typically that you see? You know, with batteries, I think, you know, it's like 10 years of life. So how quickly can you have the depreciation kick in and, you know, pay back with the tax?
Yeah, so if you use maker's depreciation, we typically use a 5 to 7 on accelerated. Last year with Donald Trump and his write-ups, we did year 1 depreciation. So it does, you know, if you can do do 100% depreciation in year one, that's very attractive.
Yeah.
So you really need to watch it. It changes a bit at the federal environment, so you need to pay attention to that. But no, on a finance solution, which many of these we do finance, and the most common is through like a solar PPA style, where you incorporate battery storage, solar, and microgrid into a single per kilowatt hour price that the solar system produces, and you pay what it produces. We are able to take advantage of the federal ITC, the battery storage incentives, depreciation, and that tends to be a benefit for the host customer. There's a good question here. Are there recommendation softwares for modeling microgrids? Not that I know of. There are softwares for solar and storage, but that's really just an economic and sizing energy tool base, folks like that. We have our own proprietary system we use. I have not seen any off-the-shelf microgrid modeling. Most of what we do, unfortunately, is manual. Well, there's parts that are automated of it, but many parts of that are manual and really sizing the load, what is critical, duration needs, and then tying it back to more automated software platforms. Sorry, that may be a great idea for you to develop one.
Well, I know like Lawrence Berkeley National Lab does have a modeling software, but I haven't used it, so I can't comment on that.
Yeah, I did a couple of projects with LBL and Berkeley Labs, and when we got into the details of that, a lot of that was custom.
Mm-hmm.
So they've got the intelligence to do it, but the entry points are pretty rigid, and so you tend to doing a lot of custom work on that model. And thank you for who's putting in the Homer Pro and Homer Grid. I have not used those, so now you've given me some homework, which I like. Thank you.
So do you typically prefer to use the interval data, the 15-minute data which is there, or what exactly is your approach? Like, is it like kind of measurement and verification on the main meter, or what kind of approach do you follow?
It varies quite a bit, and I'll tell you why. So typically we'll start off and we'll come to a client and we'll pull 12 months of 15-minute interval data, and we'll look at what their load profile looks like. And then we will size the solar system. Well, then the next thing is really what critical load do you want to back up? If it's a whole building, then we can just use that 15-minute interval data and size solar and storage or another generation asset to that. Most don't do a whole building. Most do a subset of a building. So then the question is, what are your load calcs for those lines that you want to back up, and how do you get them? Very rarely do they have sub-metering. Some do, the newer ones do, but most situations they do not have sub-metering on the circuits that you want to back up. So you've got to do an engineering load calc on what those loads are and what the energy consumptions are and when, and then back that into a total amount of kilowatt hours that you want to consume on a daily basis or monthly basis, right? Then you have to size the solar based on how much it will produce year round, and are they willing to go negative in certain situations in the winter? And then you size your battery storage to those requirements to be able to handle any of the reduction in solar or non-solar producing hours, so they can run that facility 7/24 or that load panel 7/24. So now you've come back down to, okay, here's all this, right? So now I have the solar size, the battery size, the curtailment load size, the duration is the next question. Do you want to be able to do it for a day, an hour, a week, a month? And that just extends all the sizes. And then you can actually start running financial analysis.
Mm-hmm.
So that's how we typically look at it.
Yep, thanks.
And there's a lot of detail below that curtailment that I didn't talk about, but the question is, how do you curtail the load, right? Or how do you create a critical load panel?
That ties into, this is Sean again, that ties into another question I have with regard, from an M&V standpoint, measurement and verification. A lot of, I did a lot of M&V, and a lot of it depends on a really good understanding of the operating model of the facility you're working with. And so if that operating model changes going forward, your forecasts sort of, you know, they're not going to be as valid. So I guess to what extent does those conversations with the client involve what are the plans of the operating model and whatnot? Do you get where I'm coming from?
Yeah, we do. We definitely do a lot of discussion around future loads and what's adding to it.
Right.
You know, how old is the existing equipment? What's the replacement? Are you adding, you know, EV charging? Those types of things. But one of the nice things about intelligent battery storage is we always see buildings that change, right? And as long as they're within certain boundaries, where the battery storage system is able to accommodate those. And so the question is, how much buffer do you put in the battery storage capacity to do so? And as part of the initial design, we can put in a factor of, you know, a 15, a 5, 15, 30, 50% utilization change into the models to say, here's what we'd recommend and why. Because if they come back and say, you know, I'm adding on a new wing, or I'm adding electrifying this, or I'm switching my natural gas to, you know, my CNG compressors to electric buses, you know, they have big impacts to the energy utilization. And so we try and help them plan for that. But the key is having an intelligent software that manages the battery storage system or the microgrid, or works with the microgrid, to be able to let the building change, the building load change and utilization change, so that you extend the value of that install.
Yes.
Steve, this is Tim Clark. Would you give us your perspective on the future of the public power shutdowns? Are the utility companies getting better at predicting the shutdowns and maybe shorter duration? Are they getting better at their vegetation management programs? Or is the severe weather growing, and so that we can expect more shutdowns in the future?
No, I can't. I sit on a CISA group, and we deal a lot of what we're trying to expect is happening with utilities of both SCE and PG&E, to a lesser extent San Diego Gas and Electric. But I think PG&E, given the bankruptcy and the funding for vegetation right now, is and their hypersensitivity, I think, to just the deaths in paradise and the cost of that they're going to shut down more, because getting blamed again for another fire where they didn't do this is a real worry. I think for everybody, not just PG&E, but for a lot of stakeholders in this process. And so I think you'll see more that'll be less duration, because they'll be able to be smarter. But you have to tie that with climate, and just seeing the higher heat and the less water and what those predictions are means we're going to be a little drier. So this is going to be a tough fire season. With, you look at the snowpack right now, and the anticipation is we are going to have more events this year than we did from last year. So what I'm hoping is some of the intelligence, and a lot of it's factored by wind, dryness, etc. And there's a lot of microclimates that are in here where it may be 30 miles an hour on your hill, and you literally go 3 miles away and it's 50 miles. So how do you drop power and add controls into those areas for you know, a smaller region? And I know they're working on developing that, but those are months and years away of small local containment of substations that you can really identify and isolate. So I think longer term will be better, but I think shorter term we're going to see more.
Good, thank you.
Yeah, and they are aggressively looking for shovel-ready projects to fund to install before the fire season, which tells me they're a lot more worried.
Yeah, I've heard the sorry.
Hi, this is Hasna. Can I ask a quick question here?
Sure. I think we'll go you first, and then we got two others, I think, after you.
Okay. Just wanted to know about the microcontroller designers. Are they around that we can, get to talk to a little bit to do the customized design?
You're talking some of the engineers we have on staff or just in general?
In general.
Yeah, there's quite a few consultants out there. There are a number of companies that will develop microgrids. I mean, you probably know Schneider, JCI, there's quite a few out there that are building these. And so what I would do is if you just Google search microgrid controller, you'll get enough manufacturers out there to start talking to a few. And I think that would be the best way to sit down and figure out what you're comfortable with and who you're comfortable with for your specific solution.
Okay, thanks. Yeah.
I think there was another gentleman that was asking a question that it is now open
again
for anyone to ask a question.
All right, so this is Sean again, and I know that there's CEC money available for the microgrids, but is that administered by PG&E? I know PG&E is very hungry for microgrids, as you mentioned. So is it administered by the utility level, or is it more, are those things, the incentives around microgrids more administered by the CEC?
It depends on the funding source. The EPIC funding is managed by the CEC, which is looking to deploy microgrid technologies, and they have a couple of other funding. They have some ones that are active right now, and they have some new ones coming up to help on that. The biggest incentive that you're seeing right now for microgrids is through the California SCHIP, which is funded by the CEC, but administered by each of the utilities. So PG&E, they just had an opening on, it was May 12th was the close date, and you had about $360 million of applications for battery storage through that, which is about 360 megawatt hours, which was about 300 million of funding. And they're working through that. They've already awarded 100 million of that, and they did not expect this amount of response. And so they are trying to figure out how to accelerate the funding of the additional 500 million for those projects.
Okay.
But like I said, our state elected officials see this as a big issue and are finding a way to divert and create new funds to support more microgrids to alleviate some of the issues that we saw. How about any other questions? How about any questions around electrification of fleets? That is my favorite topic. If anyone's excited about that, I would love to talk to you guys about that.
Actually, I got one again, Steve. I'm just curious if I'm setting up a microgrid. I'm just wondering, like for the bus that I'm going to put all my generators on it, what the advantages would be if I were to, let's say, use a DC bus or versus an AC bus.
So when you're doing your design, right, the question is how do you tie into the battery storage into your, if you've already got an existing diesel gen set that is powering whatever you need to power and you're just complementing that with solar and storage, we will typically tie in wherever that critical load panel is behind the switchgear. And we are typically using a battery storage system that connects in on the AC side. So it'll convert, it's converting, I'm sorry, the batteries are DC, it's converting to AC when we tie in. Now we do have a number of installations on the East Coast where we're taking solar and storage in the same inverter and we're doing DC to DC, but the economics are not as attractive. It's coming, but I think you will see the line losses are definitely more on AC, but not to the level of the difference in price. So most of our installs are AC coming into that. But I think that will change over time.
I was thinking more like frequent phase and synchronization, and other power quality reasons. That's actually why I thought it might be going with the DC bus. It's like a brand new system for a brand new building would be the way to go, just because you only convert. You don't have to worry about like making sure everything all the AC waves is formed, as well, line up at the same time, because there's like one point of conversion at the end. That I don't know. Is that that part of an issue? And these to deal with an AC, just a straight ordinary AC system, or not? Because I was actually kind of like, well, I was thinking about going with the DC bus actually.
I have not seen a lot of issues with the, I mean, typically the sine wave out of solar and storage is cleaner than what we're seeing from the utility. And we have installed battery storage. It is kind of a unique situation as a power quality tool, but usually that is not the main benefit of installing that. Usually there's other technologies out there that could clean that up better. I have not really seen a comparison of DC to DC versus an AC storage inverter and the pros and cons of quality of the sine wave. So I don't have enough data to know if I can really answer that. I just haven't seen that comparison. So, but I'm sure there's a lot of electrical engineers. See, this is why I was a double E, and my last year I switched to industrial, and I should have stayed another year because then I could have probably answered that.
Oh yeah. I need to ask the guys that like working with imaginary numbers, basically.
Yeah.
Yeah.
Okay.
Right.
Steve, thank you so much. This has been a great presentation, very, very informative. Obviously, you are a subject matter expert. So, and we will take you up on that offer to present on electric vehicle fleets in the future. Thank you for, we look forward to that. Nishant, you wanted to mention some of the ways that people can stay in touch with the chapter. Why don't you go to that slide and talk about that, and then we'll draw this meeting to a close here soon.
Thanks, Tim. Thanks a bunch, Steve. All please feel free to reach out to Steve at stevekelley@engie.com. Please visit our parent organization, Association of Energy Engineers. Also visit our website to subscribe to our newsletter. AEE NorCal conducts energy-related events in the Northern California region and gives away scholarships each year. Consider reaching out to us through one of these channels and becoming our member. Thank you.
And while you guys are, or you folks are writing down Steve's information there, please give us a little feedback on how you enjoyed the presentation, any comments, critiques, and maybe even let us know if there's future programs you'd be interested in us presenting or hosting. So with that, Steve or Nishant, do you have any final words? Other than that, I think we could adjourn for the day.
No, you're welcome, and thank you for the opportunity. It's an exciting part of the field, and the more smart people we get paying attention to this, the better solutions we're going to be able to create.
Absolutely. All right, with this, we are closing the presentation. Thanks everyone for joining us.